Like, what can he do? What is the amount of damage the guy can do? So, because the whole, for context, is we want to be able to determine, like, if someone has access to your Kubernetes cluster, what what is the container process basically the person can run, and it basically leaves the isolation, the container isolation stage. And the way I say Kubernetes most times is just like visualization on steroids, basically. So um, think about security. You guys know we have security in layers, in levels itself, and it depends on how serious you can be. And if you notice, there was one recent incident that Uber got hacked, and the attacker just entered the Slack group and like, I just hacked you guys, legit. So it's very very funny. Wow.
Guys, 1 hour, please. It's not fair that this guy came this morning and is preparing to talk and we are having our meetings. There will be time for this. Thank you very much.
Okay, thank you. So, because of time, let me just go straight for it. So, when it comes to Kubernetes itself, right, we want to basically limit the damage anyone can be able to do. So that means we have like levels of security levels or best practices that by default Kubernetes provides, but then again, they're also open sources. So the very first one, okay, cool. Okay, I'll just continue. So the very first one is there are a couple of them. So most times we look at like from a pod level. You all have pods running on your Kubernetes cluster basically, but on a pod level, what can you do? So they're basically standards that Kubernetes like by default provides and open sources provide. So let's just say OPA is there, OpenPA, OpenPA, yeah. Then you have like PSS, which is like policy security standard. So the whole concept of this is there's a way you deploy your when a pod is going to be scheduled. There's a way that you want a standard, like a different standard that your everybody in your company should follow. And if someone goes do not comply, then the pod should not be created. So basically, you know that a pod itself is just like running on just to say like higher layer. But then again, there are certain processes people can perform, and at the end of the day, they can have access to the host itself. And that means if you have access to the host, just like you have access to the node, and you can do whatever you want to do. So certain things like privileges, like when you're creating your pod privileges, you want to ensure that your pods do not have privileged permissions, because by default, privileged permissions has like what's it called? The default pseudo Linux capabilities. So it's kind of dangerous. Then uh, anyway, let me just move on. So that's pod security. So think about it on that pod level. You want to define like what are the standards, what are the feeds you want to allow. You do not want someone that can enter your pod and at the end of the day, what the person does is he can be able to like write something to your host system. So if you get familiar, you will see like some certain feeds where like some host specific feeds that you can set so that people are not able to like write processes or write certain files to your host system, such as the is basically runtime security itself. So when it comes to runtime security, basically, you know that in Linux itself, when someone enters Linux and does something, there are certain syscalls that you can make, right? But those syscalls can be dangerous if an attacker enters your code. That means it can basically run anything. You do not have any limitation. You're basically giving the guy like do whatever you want to do. So as much as possible, you want to like from a runtime perspective, let us restrict the number of or the amount of syscalls or certain syscalls that you know are quite dangerous. So what you do there is, I know Kubernetes by default provides like second is specifically for syscalls. So it lets you restrict syscalls that you make from your Kubernetes pods. And one of the most interesting thing is, I think for the latest version of Kubernetes, like 1.14 or something, there's something called default runtime. So if you use like container D basically for your Kubernetes cluster, by default, what that gives you is you can basically enable a flag, and there's like a list of syscalls already defined for you that Kubernetes makes it easy. So when an attacker gets into your system, there's there's a limited amount of syscalls you can make basically. And there are also other open source like Prisma, Aqua, Keveno, and every other thing. But most times, okay, I'll talk about it in image security. So image security, and after image security, then I'll go to network security. That's where our talk is about today. Image security. Now, let me tell you guys one fun thing. You know, most times you deploy Nginx. You deploy Nginx is basically like your front end if it's a Kubernetes cluster, or basically any layer 7 stuff. Now, um, sometimes we deploy stuff, but we don't actually keep track of what's happening. So, aside best practices when you're building your Docker files and your images, do you actually keep track about your CVs for your cluster? For instance, you deploy like to Nginx, and Nginx running fine. It's serving your customer all fine and well. But tomorrow there is there's a vulnerability that has been discovered. You guys do not know. So at the end of the day, what if an attacker exploits that vulnerability? How many of you here love open source? Open source. You love it. Yeah. I love open source, but open source is a pain. Legit. Because open source has lots of dependencies. And at the end of the day is how do there are a lot of developers here now, you guys are writing codes. Now your codes and standards are whatever you write at the end of the day, they can be exploited. So if, for instance, you're not updating your Nginx images or whatever, what that means is you're not scanning in a real time. There's something called Trivi, right? I love Trivi because I use Trivi. So there's something called Trivi, and basically from your pipeline, when you're running like your builds and every other thing, you are able to scan in real time based on the database, just compare, and at the end of the day, it gives you like if the critical, the medium, the high vulnerability. So basically, what that means is you have an idea of how secure your images are. So tomorrow in my cluster, I've been running like a certain application. Let's say I have a Python application. What happens when a vulnerability is discovered and you do not know? It's running fine, but at the end of the day, you're not scanning your images in your cluster. Understand something. When you deploy an application, that image itself may not have any vulnerability because the certain package has not been exploited, SSL as well, and Grafana had it and a couple of packages. So if you were not like scanning those images itself and maybe your Nginx is just running fine and you're just fine, one day someone will come and exploit something you do not know and he has access to it. And based on how high that CB is, determines like the damage the guy can do as well. So that's one thing about image security. And then I'll talk about what's it called? Um, what's it called? Sorry, secrets. Now, for secrets itself, we know most times at the end of the day, we write secrets as an environment variable. But you know, most times I tell you that security is as layers, right? Depends on how far you want to go. What happens if someone execs into your pod and just run END? All your secrets out. So if at the end of the day you haven't implemented pod security or certain levels of security, it means that it's just like pending doom waiting to happen if an attacker gets into your cluster itself. So most times people try to like as much as possible see how best they can actually like remove secrets from the pod itself. But that's another conversation entirely. So today, I'll be talking about network security, specifically using Cilium, the other open source. But Cilium is an open source, and I'll tell you why I based it on Cilium itself. Now, you know, in Kubernetes, people talk about the developer angle. It's so sweet, you're all developing, but not everyone really talks about the networking layer of things. So that's where we're talking about. So specifically, they have like Calico, we have like Cilium itself. But today we're going to be using Cilium. So Cilium is basically like an open source software powered by eBPF. Please don't ask me what the meaning of eBPF is. too long. But basically, I think it's an extended Beckley packet filter. So basically, Cilium is just three words: networking, observability, and security on the networking level. Now, Cilium has a lot of products, honestly. Like, it's legit so much. Even AWS uses Cilium CNI for some of their, I think, outposts or something by default instead of the AWS VPC CNI. So that will tell you like what Cilium brings to the table itself. So with Cilium itself, is if Cilium is basically an open source software that provides more amazing stuff for us for networking security and observability, what then does eBPF do for us? So basically, you know how you have JavaScript, right? JavaScript, and you have developers. Now think about eBPF as a programming functionality for kernel, kernel developers. So most softwares you have them built on top of the kernel, anyone can kernel. But at the end of the day, what happens for EBPF is more like a programming language for your kernel itself. So you can imagine that you have something that is integrated into your Linux kernel, and you can imagine how much information you can get. I'm not saying like it's like standalone, no, it's integrated inside it. So every six calls you make, everything you do, you can get observability, networking, and security. So Obo basically is more like so if at the end of the day everything transcends basically through like the kernel itself, and you can get observability into what is happening in the kernel itself. So Cilium has something called Hobo. So it's more like a UI where you can see what's happening like traffic basically that's happening. So this time I have to like go. I don't know if you guys can see, but honestly, I had to just paste it here because it's gonna be too long. So this is Hubble UI itself, and what happens is if you can't see, can we turn off the lights, please? So for Hubble UI itself, it's if you have like a pod running on a specific namespace, what Hubble UI does is it shows you like what's it called? The like traces like from one pod to the other. What are the requests that pod is making? So yeah, at the end of the day, it gives you like a visual map of it itself. So the basic rules for this is basically I'll just say ingress and egress. Ingress is anything that is coming into your cluster, sorry, into your pod or into your services. Egress is what is leaving, right? Ingress, egress. So, see. So, Cilium itself supports three layers, layer 3, layer 4, and layer 7 itself. And to cut a long story short, Cilium has different ways it works. When I actually did this, I thought it was going to be bigger, I could zoom in, but it's a pain. But let's just say they are label based for the layer 3 level. That means like basically, your applications, when you deploy them itself, you label them. So, and you know how services work and pod works. It's through your labels, basically. That's Kubernetes. But for Cilium itself, it uses labels, and you can also use services. But services only works for egress and not ingress. Entities are more like a cheap API, right? Think about, yeah, you want to connect to the world. Entities are more like outside your cluster, right? So these are like categories. And if at the end of the day you want like specific IP addresses or CIDR ranges, then you put this there as well. Then it's a DNS based. Like DNS based are like, those layer 7 stuff. Like maybe you want to talk to pipeops.com. So what happens is you come here and you put a rule for pipeops.com. So I don't know if you guys can see this, but this is ingress. So ingress itself shows like basically the endpoint itself. Why this is egress itself. So what I did was I did this for service, I did this for ingress, just places like that. But I have like a demo, so I'll probably explain better there. Okay. Um, okay. So basically, let's say that I have a pod. I have a pod called, that's where we want to look. Sorry. Can you go? See, we'll manage. So let's say I have a pod, I have a namespace called Edera, right? If you guys are into Web3, Edera, like the coin Edera. So if you guys have like a namespace called Edera, and basically it means that um, your Nginx is a pod running. Let's say we have 3 pods running. Nginx, right? We have, yeah. Okay, I'm looking at the second one. The second one. Okay, I just have to explain it. Sorry. Yeah. Okay. So now imagine with me, right? Sorry, it's more like electrical engineering again. So quickly, please. Imagine we have like in the namespace called Edera, we have your Nginx pod, which manages like traffic to your pod itself. Then you have like an Edera pod itself, which basically do whatever it does. Then you have like, let's just say those two. Now, when you deploy a network policy, now Cilium itself, we are using Cilium to deploy network policies. By default, Kubernetes provides its own native uh, network policies, but the constraint there is you don't have visibility into layer 7 traffic. So hence why Cilium is even cool. And then again, most cloud providers allow you to use Cilium CNI, which basically provides those features I talked about. Now, so what you do is from an ingress level, let's say Edera itself. The ingress port talks to Edera. Now, if you deploy a network policy which is like very addictive and you have to whitelist it, by default, there's a default deny on that namespace. So what that happens is when your port comes up, basically anybody that enters into those ports, they can communicate with anything. Like you can reach the port and the port can reach the internet. So what you have to do, you have to define rules so that those rules, you can then say, okay, let me allow Nginx to talk to Edera, right? So that's my port itself. So that's ingress. Then you have to specify a port itself because as much as possible, you want to be very restrictive. You understand? So you allow Nginx, let's say on port 3000 to talk to it. Then egress itself, let's say I want Edera to talk to Pipelines. I don't know why I'm calling Pipelines for. To talk to Pipelines, right? Now, what happens there is I have to use like something called like DNS. Like I have to put pipeups.com and put like, let's say I only want traffic to leave that port 1443. So once I apply that policy, what happens then is by default, there are only two things that can talk to my Edera port, which is my ingress and my Edera port can talk to pipeups. You can do from now to tomorrow, nothing will work. And it will pain you. And at the end of the day, sometimes when you're deploying, you then remember that, oh shit, I actually deployed network policies there. So you can see if an attacker gains access to your pod as at that point, how much can you do? Let's say you've employed like pod level, you've done network level, you've done like security level. You understand? So as much as possible, you're reducing the attack surface. So the last slide itself is I did like kind of test. Okay, you manage this one. So I'll be quick, please. For the last slide, I'm doing a test where, by default, right? AWS, let's use AWS for instance. AWS has an endpoint that you can call this IND something, basically the easy to metadata API. Do you know that if you go into your port today and you call that endpoint, it can return some service account tokens and some roles? So that means an attacker can use that and break out of that process and he can do whatever he wants to do. So, except you migrate to the version 2, basically where the attacker needs like a token. But if you're using the version 1, you're just waiting for a problem. So, let's say I did like, I have 2 pods running. So, Edera and Edera ingress, those are my 2 pods. Then this CNP is more like my Cilium network policy. It's more like a CRD, basically. So I have one policy for my Edera pod. I have one for my ingress. Because why? If I do not allow my ingress to, what's it called? Sorry, this is test namespace for. or ignite. But basically, for this ingress itself, if I do not put like an egress rule to say, please talk to Edera, and you put an ingress rule from Edera that you are expecting traffic from Nginx, it will not come because it has to be done from both sides, egress, ingress. So when you say get Cilium endpoint, basically it returns like some stuff basically. Now this is me doing a test. I want to make like a call to this metadata API. I did not apply any Cilium network policies, which should be your cluster, basically, if there's no network policy. I come in here and I say, oh, guy, hold this endpoint, which is 169 blah 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 metadata. This guy legit brought out everything for me. Like I could do, if I was an attacker, I could do what I want to do. Then the second one basically is when a policy is applied and sorry, well, you guys will have to manage. Sorry, that's it. Okay, okay. So the second one basically is when a policy is applied. Yeah, you can see what happened. So because I, let's say I created a route for Edera and I said only go to pipeups or nautilus.com, for instance, because I never allowed an egress rule to this IP address by default, it times out. So in summary is um, security is quite large itself, right? And in Kubernetes, most times we ought to actually think what are the measures that we can actually implement for as much as possible reduce the attack surface. Everything works together in tangent, but network security is actually important because you want to also see the request your services are making. What are your services denying? You want to have control over it. So when an attacker gets into that spot itself, there is not so much he can do because the guy will be so frustrated because he can't get maybe download some certain things from the internet. Yes, if network policies are applied, you can't even download some certain packages from the internet because, like, let's say you want to go to NPM registry, it won't. It will fail to time out. So at the end of the day is uh, Cilium is great, and eBPF, most times if you guys see anything by eBPF, look into it. It's actually great. It gives you like lots of observability, networking, and security itself. So this is what I wanted to share with us, basically like implementing network policies using Cilium itself. You can do this in your environment itself, but it can be a pain as well because then again you will always have to debug why it's just failing. But at the end of the day, do not wait to be exploited before you know that why did I not implement this? Thank you.
Okay, thank you so much for this wonderful presentation. So my question is not a question, just for you to say the serial network policy based on three policies, based on three.
That's okay.
I just take it for experience.
Okay. So it's basically on three pillars like networking, security, and observability. Why? Because it has visibility into your kernel. So what happens is whatever syspos you make, I can see it on the UI. I can see it, so I can block whatever I need to block. And in terms of security itself, um, now, network policies basically. But then again, think about it. You can also deploy because it has other services like cluster mesh services. So what happens is if you deploy a network policy, you can then decide to say, okay, I want to like replace like cheap proxy, let me use a certain service. So at the end of the day, it has like lots of services that you can utilize for your security. Yeah.
Thank you for
Yeah.
my question really is I've not seen them before, how Okpako. Then Okpako is just what you just described, say you are setting your network policy and you can get these things done. So I want to know what is actually that edge that Cilium provides over, say, every other.
Okay. Yeah, quick one. So before I used Cilium, I tested with Calico. It was a pain. But let me answer your question. First of all, yeah, do you know that in every cluster that you run, there's something called like a CNI, right? Now, Cilium by default has its own Cilium CNI, which, so basically, I would say this, right? For me to be able to implement layer 7 policies on Cilium network policy, I basically have to remove like AWS CNI and put it there. So I could basically see that if I want to go to like nautilus.com, I want to go to nautilus.com/frank. Only that part should be allowed. Any other part will be denied. So, so that means you have something natively designed for your Kubernetes cluster. That's one, Cilium CNI. Then two, Calico does not have like a lot of like services that Cilium has. Yeah, Cilium has like UI. It has like lots of services that you can build and expand. So the integration is more smooth and it has more services. And basically that's why for me I use Cilium itself. Yeah.
Thank you.